Okay guys, welcome back. In this video we're going to talk about the next part of the hypothesis test. After we've established the hypotheses, we look to something called the significance level. So that's what we're gonna be dealing with. So again, everything that you see in red here is what you would be writing in on the guided notes for the sections 10.1, 10.2, and 10.4 that you again can find on the Canvas course website. So it says once the hypotheses are established, we next move to compute what is known as the p-value. So the p-value is the probability of getting a statistic as at least as extreme as the one we found from our sample. And we use the test statistic to make a decision about the null hypothesis that we derive the test statistic from. So a lot of vocabulary words going back and forth here. So let's make sure we can make some sense out of this. This word test statistic is really a fancy name. Let me make this a little bit bigger so you can see it. Okay. This word test statistic really is a fancy name for z-score. Okay, so let's write that down. So test statistic really means z-score. Okay, so a very fancy way of sort of framing that. Okay, so a sample statistic is said to be statistically significant. So that's an important phrase, okay, that we'll hear quite a bit. If it's far enough away from the presumed value of the parameter to conclude that it would be likely for the sample statistic to occur by chance if the null hypothesis is true. So what this is saying is that if our probability is small enough, we say that then that this test is statistically significant, which then means that this particular sample statistic that we have is indeed far enough away from the parameter. So it's an extreme. And so the question is that a good thing or a bad thing? And that just depends on the type of test that you're running and what you're trying to compare. So for example, is it a medication and we're trying to see if it reduces people's pain levels? Then we want something that's statistically significant if it's reducing the pain. Okay. Now we have something called the level of significance, and it's denoted by alpha. So alpha we've seen before when we talked about confidence intervals, if you remember back in chapter 8. And so we have alpha is equal to 1 minus c. Okay, so that little formula is back. So it says if the p-value of a test statistic is less than alpha, we say that the test is significant at level alpha. So it lets us say whether or not the data is in favor of one hypothesis. And so alpha is always a value that we decide on. And usually when you conduct research, the idea is that you pick alpha before you run your experiment. You don't do it afterward. And usually the most common value for alpha that we use is 0.05. Okay, and so what that means is C is 0.95, right? So alpha is 1 minus 0.95, which is the 0.05. And again, that's the common one that we use in most tests. The smaller alpha is, actually the better. Okay, we say the more stronger the test actually is. Okay, or the more significant potentially our results. So if you've ever seen a journal that has hypothesis tests, they'll often list different values for alpha, and they'll indicate which ones the test was significant for. And so the smaller that level of alpha, the better. Now we've got two decisions that we can make for the hypothesis test, just two. So the first is to reject the null hypothesis, and the other is to fail to reject the null hypothesis. And so you'll notice this is always in terms of and in reference to the null hypothesis. Okay, so that's usually how it works. So it says if the p-value is found to be statistically significant, which means it's less than alpha, then we reject the null. Okay, so once again, if the p-value here is less than that alpha, then the decision is to reject the null. And if that p-value is greater than alpha, then the decision is to fail to reject. And this will make sense once we look at a hypothesis test. Okay, so let's look next at the steps for the hypothesis test. And in my classes, I usually teach that there are 5, and so they're listed here. Okay, and so what we will do is we will make every attempt to list out those 5 each and every time we write a hypothesis test. So the first is to state the null and alternative hypothesis. We've done that. We've done 3 examples in a previous video. Next is to compute the test statistic. Remember, this is simply a fancy name for the z-score. Okay, and to do that we have to use the central limit theorem, so a little bit of chapter 7 comes back. Find the p-value. We actually get to use the normal distribution table, so that's exciting that that's back. Maybe it is for you, maybe not, I don't know. Number 4, we compare the p-value to the given level of alpha, that's the level of significance, and we make a decision. So those decisions were right here. That's what we were looking at before. These are the possible decisions, okay? And then the last step is to write the conclusion. And what you do there is you answer the question. So usually the question is there enough evidence to suggest X, Y, and Z happens? And so that's what we take care of. All right, what we'll look at next is error types.